goes live, and then
Yeah.
yeah. I see a ZKGM. That means that we are live. I don't have to
ZKGM.
double check, but I'm going to check again because we have to go live from two platforms. One is our YouTube, and that's where like I'm seeing a lot of messages pop up. But I think we are also supposed to go live from our ZK Sync Devs account on Twitter. So I'm just going to double check if that happened. Yeah, I think we are live. Hi, Porter. Awesome. All right. I think we are good to go. Hi, everyone. Welcome to the second Builder Sync session. I'm going to give it like a few seconds for like just everybody to kind of roll in. I've dropped a message in our builders group chat that we have. So I'm just also waiting for all these people and all the builders and all the developers to join us for like one of the amazing or exciting topics that we're going to touch on today, which is native account abstraction on ZK Sync era and how you can build or create smart accounts using WebAuthn, right? And again, like if whatever I just said like doesn't make sense and like make sense to you, like don't worry because we'll really like break it down for you all, like what we mean by account abstraction, what we mean by smart accounts, and how you can get started building with WebAuthn on ZK Sync era, right? So just a few moments, like let everyone come in. I see a lot of hellos, I see a lot of GMs. But in the meanwhile, Sarah, if you want to give your intro or like anything you want to say.
Yeah, ZKGM. Hopefully you guys have seen me in one of the earlier live streams I did about like building custom ZK chains. So this has been like the next big tutorial that I was working on. It's called like signing transactions with WebAuthn. And yeah, I'm super excited about it. I put a lot of did a lot of research for this. I think I made a pretty cool app, something that I wish I would have been able to find like a couple months ago when I was looking into this. So yeah, I'm thinking you guys will like it, and you'll be able to build something a little bit different than you're used to.
Yeah, and if you,
Yeah.
sorry,
No, go ahead. Yeah.
I was just saying, like, if you haven't already checked the demo video that Sarah shared on her profile, don't worry, you don't have to like start stalking at this point. Like, we're gonna share everything to you, the written tutorial as well as like in this workshop, we're gonna go like hands-on from 0 to 1, literally, and we're gonna show you what exactly we're gonna build so that you have some visions or you have like some intuition around like, okay, these are the features that we're going to end up building, and these are the steps into like how it leads to building um, certain use cases, right? um, yeah, I'm gonna wait for a few more seconds before we really start. We have a good crowd gathered already, but yeah, I just want more people to join. This is one of the most exciting tutorials out there. There's just like a lot of things that you can learn out of this tutorial that Surah has written. First thing is basically, I guess you'll just learn the intuition around the native account abstraction, right? What does that mean? You're also going to learn about how to build with WebAuthn. And I think WebAuthn itself is really interesting. Like, it's just an API, but the kind of use cases it enables is very cool. Like, I feel like a lot of people are still using passwords for a lot of different apps and dApps. And I just feel like passwords are kind of like very 2017, right? We don't have to use password at this point. Like it's just too much work. Like you have to remember what password you put like on a certain app and dApp, and like if you forget, like there's like a recovery that you have to go through. Like we don't want all of that shit, right? So why not we do something with the devices and hardwares that we already use, right? So this is really interesting, and it kind of adds to the point of making sure that we have a good UX for builders, for also like for the retail or the user, from the user endpoint, right? We want to make sure that the onboarding for users are very smooth. So we're gonna see a lot of things on the demo side as well, which Sarah is gonna show in a bit, literally in 1 minute. Yeah, so I'm really excited about this. Sarah, if you wanna set things up for the demo, like let's just start doing that.
Yeah. Okay, let me share my screen. Okay, so this is just a quick demo that's on my Twitter that shows what the project is. Okay, so I'm going to pause it real quick actually to preface that. So if you can imagine like your typical Web3 experience of like going to an app and signing a transaction, like you have, and just sort of like how foreign that is when you first do it. Like you have this like wallet, you have this like private key and a seed phrase. It's like back this up, and it's like not this great experience. So you've probably heard about account abstraction and what that is, and it's basically like the ability to have like customizable rules for your accounts, like you can do with a smart contract, um, and that can enable things like not having that wallet extension like in your app experience. And one thing I like about this demo is like there's a lot of different ways you can use it. So it's really meant to be like a demo in that like I don't want people to like exactly copy this and like run with it. It's definitely something like you could go different directions with it. So I'm going to show you what that looks like. There's 4 buttons in the app. Um, excuse me. The first is create an account. So imagine like you don't need a wallet to go to this app, right? You just go create an account. The next is register a passkey. And you might have seen this for other websites, like where you can use like a YubiKey or something like that to like do two-factor authentication.
This is
Um,
interesting because yesterday only, like I set up my UV keys and it was like a good, like I was like, dude, why was I not using these keys before? Like I don't have to remember password. I just like, you just plug it with your device and that's it. Like you're set for all the things. And like this security wise as well, like it just makes sense, right? Before anyone, like some smart hacker, like we don't have, I mean, we have a lot of them in this our space. So like we have to like double, like we just have to make sure that like we are taking like right steps towards security as well. So yeah.
exactly. And like, so what's going on here is like when you're registering a new passkey, it creates like a new private key pair like on your actual like physical device. Um, and like some devices have like a trusted execution environment where it stores that, so it's like super secure, like this passkey. And so basically like this is sort of like you can think of it as like making a MetaMask wallet in 2 steps, I would say. Like where the first step is like you create this like smart account address, and the second step is you generate like a private key pair that's like a separate account that we can like basically register with the first one. So this will make a lot more sense later once we get to the code, but what's happening here is like we're registering a passkey like on our machine, but then we're also linking it to the first smart account that we just generated here. And like when you can like create a name for the passkey and use like a fingerprint to sign it basically. So you'll notice like you don't actually see like the public or private key when you create that. But you can get that you can get that public key in the background, and like what's happening is like we're registering that key to this account we made, and we're basically giving this key like basically permission to sign for this smart account. So these 2 other buttons here, like transfer funds and then mint NFT. And so yeah, this is just an example of like, if you want to transfer ETH, you can just do it with a fingerprint. And also, by the way, everything here is using a paymaster. So like, what is a paymaster? It's just a contract that allows you to basically sponsor transactions. So there's no gas. So like we just sent 5 ETH. So this smart account we created like got some test ETH. They got 100 ETH because all this is running like on a local test node. And so yeah, it sent 5 ETH, and you can see like the balances after are exactly like it's 95, and Like when you have to pay for gas, it's always like some weird number. So I feel like just for UX, like it's so nice to have that. Yeah, so transfer and then mint an NFT, just showing like how you can use this with a contract. And it mints you a cool Zeke NFT.
Amazing. I think we saw four things. First was basically creation of your passkey itself, um, and then you're creating the smart account, and then you're doing two kinds of activity. First was the transfer of tokens itself, and the other one was the mint that happened, which was basically gas free because of the paymaster contract that we are going to be creating soon.
Exactly. Yeah. So yeah, I can see like if it's, you know, if this is too crazy an idea for you, you're like, okay, this is like so far from like what I'm used to in Web3. Like I feel like the closest use case that is really cool to think about is just like account recovery. That like you could have an account where like you are using like a normal wallet or whatever and like use like the normal flow that you're used to, but you could have like a pass key that is able to transfer funds, like just transfer all your funds, like just in case you lose access to your account. And like you could potentially add like multiple pass keys, and just like have that ability to like back up your account in different ways. So yeah, so the tutorial for this is at code.zksync.io, and everything you need to know about it is there, and we're going to go through that. So is this, can people read this? Okay.
Yeah, it's visible. Yeah.
Okay, cool. So you guys saw through the demo like what we're gonna build, but yeah, so just sort of break it down a little bit. So we're going to create a smart account, and it's going to be a custom smart account that has these capabilities to use WebAuthn. We're going to create a front end that allows you to create a new WebAuthn passkey. We're going to have the ability to register the passkey as an authorized user of a smart account. And then we can use it to transfer ETH to mint an NFT, and all the transactions will be gasless through a paymaster. And you can find the completed code inside the community code repo. And just super shout out to the Clave team, because a lot of this code came directly from the Clave team. Like almost like this wouldn't have happened without them. They're also like a driving force behind the P256 verify precompile that we're going to use. So huge shout out to them. Yeah.
And like just a little shout out to the team as well. But if you haven't used Clave Wallet, I highly recommend going through that. Like the experience of it just feels like very web. Like you won't even feel that you're working with like some sort of Web3 wallet. It's just like so seamless. You don't have to like at the first few steps. You're gonna mint this like dot clave, like your ENS kind of address, but like on Clave for ZK Sync, and it's gasless. It's just like things are happening. It just feels like, oh, I can do like whatever without paying gas or without having even like tokens in my wallets, right? Yeah, so Clave team, like big shout out. The wallet is amazing. So again, highly recommended.
Definitely. And I think it probably is a better demo of like what all of this tech can actually do for like a production app. Yeah. Okay, so let's get into it. So what is WebAuthn? So WebAuthn is short for Web Authentication API, and it's a built-in API into like a bunch of browsers that allows your app to register and authenticate users. So it's that ability to like create a passkey and like use Apple Touch ID on your Mac, use a YubiKey, and it's basically like a universal API for all these different passkeys and like hardware devices. And in terms of like for developers, there's like two main parts of it. So there's like creating the passkey, and then we use it to sign the transactions, right? And in like their traditional like Web2 like passkey sense, these are called ceremonies. And so the first step is registration. And so that's when you create the passkey, and then there's authentication, which is when you use it. And so how that works is like it usually generates like a random challenge to be signed, and then you like would do some validation on your server. And yeah, it also returns like a signature, sort of like we're used to in Web3.
So when you say challenge, do you mean the transaction that might come from the client side, or is it something else? Like, is there a magic behind the scene that's happening?
Yeah, exactly. So in our case, we're going to use a transaction as the challenge. So it's like, yeah, we're going to have our passkeys sign the transaction, and it's a little bit more complicated. We'll get into that in a sec. But yeah, traditionally, like outside of Web3, it would just be like a randomly generated string or something. So yeah, this is a really simple version of what WebAuthn is. And in terms of signatures, the signature schemes are different than we're used to in blockchain. So blockchain uses this elliptic curve. It's like SECP 256K1. And then a lot of like WebAuthn supported devices or like passkeys use this R1 elliptic curve. So that means that we can't use like the traditional functions that we usually use to like verify signatures, like verify that like a certain public address actually signed a message. So this P256 verify precompile is basically like a precompile contract we can use to verify these R1 signatures. So this is something we're going to use in our contract. Yeah, and if you want to learn more about like WebAuthn and get really like in detail about it, there's a ton of resources out there that are really cool. Like this WebAuthn.wtf like has, you know, a ton of stuff. WebAuthn.guide. Yeah. Cool. Okay. So that's the intro here. Next, we're going to build the contracts and actually get to building.
Let's go.
All right. So I'm going to make this like project folder here and just like copy and paste this, my terminal. And I'm just going to make a folder called zksync WebAuthn. I'll do demo because I think I already have one. Okay. And we're going to make two like folders in this project. So we're going to have like our contract, and then we're going to have our front end separately. So we can use the zksync CLI to create a template contract here. And for the private key, I'm going to use this like pre-configured rich wallet private key, because we're going to run all this on a local node. So you don't need to worry about getting like Sepolia testnet tokens. Okay. And while that's setting up, we can copy this next command, and this is just to like remove all the template code. So we're going to be making 4 contracts once this is set up. The first is like a general paymaster one, and this is just like I was saying earlier, a contract we can use to sponsor gas for transactions, so everything's free. An NFT contract, which is just like random, the Zeek NFT contract, just for fun. We won't go too much into that. A contract factory for our accounts, and then the actual like account contract code. So when we talk about smart accounts, this account.sol is going to be like our smart account. And this factory contract is just something we can use to deploy new instances of a smart account. Okay. Close. Oops. Close that. So you can go into contracts. Oops. Okay. I'm already in the contracts folder. Let's see. Let's just open this up in VS Code. Oh, whoops. Did a comma. And we can delete them ourselves. Okay. So just delete everything in the contracts. We don't need this test folder. And everything in here as well. Okay, so we have this like blank slate here, but we should have most of what we need set up. Hopefully that's readable. So yeah, the CLI like sets up all of our dependencies for us. So okay, the next is to create that contract. So just run this command. To create the general paymaster file. And this tutorial is really like copy and paste, I would say. So we can just like copy this whole contract here. And if you're not familiar with paymasters, we have other tutorials that really explain, I think, a lot better, or just go into depth about how they work, how you can use them. But basically, this contract will allow us to have gasless transactions. So if you want to learn more about that, I recommend checking out one of our Paymaster tutorials. But we're just going to be using this, like glossing over it a little bit for now. Next is our NFT contract. And same thing, I'm not going to go super in depth into this. It's just something that we can use to test out like calling a contract and signing a transaction that calls a contract, basically. Later on.
I think this is also one of the most deployed contracts out there. I think everyone has done that.
Yeah, I think there's plenty of tutorials about NFTs. Okay, so next is the factory. So this is just sort of like your think about just like contract factories in general. Like if you're familiar with that, it's pretty similar. But this one basically has this special like deploy your system contract create to account function. Again, there's also like another tutorial that goes more in depth about this because I want to focus mostly on WebAuthn. But essentially, to summarize this up, like this contract allows us to deploy instances of our smart account. So, okay, with those three contracts, the last one is this account.sol. Just make it here. And I'm going to go a little bit more in depth about what's in here. So this one's pretty long. And it uses like sort of a template version of the smart account where there's like some flow in here to do like general validating transactions with like your traditional flow, I guess. So I'm not going to go too much into that, but that's what like this is valid signature is this function right here. But I'm going to go, okay. So yeah, there's a lot in here. A lot of it you can ignore if you're already familiar with smart accounts and you've gone through maybe like our multi-sig tutorial. But yeah, this is basically I think the first important function to look at here is this validate transaction function. So this runs basically when you're sending a transaction with a smart account, it will give you this suggested signed hash and like transaction. And this is where you can like do validation on it to be like, yes, we're going to process the transaction, or no, it's not valid. So right here, we're doing this check of like checking if there's like this typical like signature that we're used to, like that's just creating like a standard kind of account. But what's different here is that we've added like basically if that fails, then we can validate like a WebAuthn signature. So what's happening here is there's like, it's first checking, is it like a standard like smart account transaction with like, you know, your normal kind of wallet account? And then if it's not that, like, do you have a WebAuthn signature? And can we check if that's valid? And if it is, then we'll like process the transaction. So kind of convoluted, but essentially what's happening here is like we're able to encode our own rules for our account. And so we're saying like we want to be able to use WebAuthn signatures to validate transactions, like, and like use that as like an authentication method. Okay, so what does this function look like? So right here we have this R1 owner variable, and there's also like this function here, update R1 owner. Again, like you could change this however you want. So you could have like multiple owners, but this is configured to have like one passkey owner of the account, or one like WebAuthn account essentially that can sign transactions for this account. So that variable is like at the top here, it's just like some bytes, and this is going to be the public key of that like WebAuthn registration ceremony. So where is that? So we have this function to like register an owner, and only the smart account itself can update that. And then this validate signature just checks that there is an owner registered. It gets like sort of creates a public key like variable from that like R1 owner bytes variable. And then it passes it to this next function here. So what happens here is first we are decoding this WebAuthn signature. What is this WebAuthn signature? It's basically just the transaction signature. So we have like access to, so we have access to all the transaction data as we're validating the transaction in the smart account. So we can like check, we have this like custom signature field that we'll see what that looks like on the front end later. But yeah, that's just the transaction signature. And this transaction signature is these three pieces of data basically all encoded together. So we have this authenticator data, client data, and then this RS value, which is basically just like a public key hex. And we'll get to more of what this all is on the front end, but basically this is like data that's all returned by the WebAuthn API that we need to authenticate the signature. Because
if I'm not wrong, like if we compare how authentication works between Web 2 versus Web 3, I'm expecting that in a Web 2 flow, we only get, like after the authentication, we only get like the signature part of things, right? But I see that there's like two new kind of data, like client data and authenticator data. I'm expecting like client data is basically the transaction or the challenge that's coming from the flow. And then the authenticator data must be coming from the authenticator itself that we set just before that.
Yeah, exactly. So I'll like be able to sort of log this and show what it looks like on the front end. But basically, when you send a challenge to be signed by WebAuthn, it doesn't just sign that challenge. It puts that challenge inside this like client data, like JSON object that has other data about the client, and it like hashes that, and then it adds it to this like authenticator data bytes, which is just like a bunch of bytes about the authenticator, and it's basically signing this whole thing, right? So it's not this straightforward like just signing the transaction. It's actually signing the transaction inside a bunch of other stuff. So there's a couple things we're going to do with this, and one is this next step here, which is we can extract the challenge, which is that transaction data from this client data object here. And we can like do some validation to see like, okay, does that challenge that we signed actually match the transaction hash? And this prevents replay attacks because there's already a check for the nonce in the transaction. So each transaction has to have a unique nonce, and you can't replay that. So without this check, basically, you could like send the same signature over and over again, because it wouldn't be checking like you could essentially like just increment the nonce in the actual transaction, and then if you're not checking that the actual transaction matches what was signed, then things can be replayed. So that's something that's tricky about the smart accounts, is like you're doing your own validation here with that. So you have to like, really think things through of how that will work. Yeah, there's also a malleability check to make sure the signature is like in the lower end of the curve. There's also these like authenticator data flag checks. I'm not going to go super into this, but actually on my Twitter, there's another, like I did a short video that goes into like what the authenticator data looks like in more detail. But they're basically this is checking like that the user is actually really verified like the transaction, that they're really there. And then this last part is sort of like I was saying earlier, like it's reconstructing this signed message by hashing this client data and then concatenating that with the authenticator data. So we have like the actual message that was signed, and then we can actually verify the public key that we've registered as the authorized owner, the authorized sender, actually signed this message and authorized the transaction. So yeah, call verifier. Last step here. So this is where we call the P256 verify precompile. So basically just do a static call to the precompile address, and we concatenate like that signed message, the signature, and the public key hex values. And then it returns this like output value, and it doesn't return true or false. It returns like 1, like in the hex value if it's true, and then it doesn't return anything. Like the output dot length would be 0 if it returns false. So we can just check for that. And that's our authentication process, basically. You can see more of like how we extract things, how we extract the challenge down here. But yeah, so basically in our contract, we have this like flow for authenticating WebAuthn signatures. So, Krinza, how does that make, or does that make sense?
It does, but I just feel like we would need to see that other video for sure. Like I think the explanation that you have, like with Excalidraw and like just the flow of it, yeah, I think that's pretty much needed. But I mean, again, like if anyone here is like still confused, like we can just briefly show them how this works, like the main picture that we have. Or the other thing I can do is I can share that link with all of you right now.
Yeah, that'd be really cool if you could share that link. And I think a lot of this will make a lot more sense once we do the front end. At least for me, I'm like, I have to see it on the front end. Like, how are we calling these things? What data are we passing into it to make like for it to make sense? But yeah, we can come back to this after too, and just sort of like review once we have the front end ready. So yeah, essentially what you need to know is like we have these 4 contracts here. We have NFT contract just to test something for fun, the paymaster to have gasless transactions, our account that has this our smart account contract, which has this like custom flow to validate WebAuthn signatures using the P256 verified precompile and extracting the challenge and verifying that against the transaction. And then we have this like factory contract to deploy. Okay, so we have those. Oops. And the tutorial has sort of like some explainers about like what this code is. That's basically just has how I walk through it. So I'm going to go all the way down here to deploying. And we're going to run everything on a local node. So I have error test node installed. It's super easy to install if you don't have it. You can find it in our docs here under test and debug in memory node. And yeah, it's super helpful for testing out things. So I'm going to start a new node there. It's running at port 8011. And I'm going to update the hard hat config here so it deploys to the local node. And another thing that this config will have is this enable era VM extensions flag, which allows us to like basically deploy these smart accounts. Okay, so we have that ready. Next is to add a deploy script. So create a new file called deploy.ts in this deploy folder. Copy the script. And yeah, I'll just deploy the factory, the NFT, and the paymaster contracts. But it won't deploy any actual smart account yet. So we can just run compile, npm run compile. Yep. All right, and then deploy. Okay, so we have these addresses here, and we're going to need these in a second. So don't close this, or you can just run the script again if you do. So yeah, we have our contracts. Now we're going to make a Next.js front end with TypeScript. Oh, I'm in this. So I need to open up actually the folder. I'll have to redeploy my contracts. I just realized I said don't close it. The folder, the parent folder here. Okay, let me restart a local node. Error test node run. Go to contracts and deploy, npm run deploy. Okay. So now we can make our Next.js front end in this folder here. And we'll name it front end. we'll use TypeScript. You can use ESLint, no Tailwind, yes, and a no to the app router. I'm sorry, I'm still on the old Next.js. Pages, and no, we don't need to customize that. So there's a few dependencies we need to install here. We have this simple WebAuthn browser and simple WebAuthn server packages just will help us like do the registration and authentication. Seaboard, Ethers, and zk-sync Ethers. And we're going to be using Ethers 5, actually. Okay. So going into the front end and just installing those dependencies. And then we can make a local env.local file for our like deployed contract addresses. And just copy what's here. Okay. So first we can do the homepage. So this is basically those 4 buttons that we saw in the demo. So we can just go into this index.tsx and replace the whole thing here. And it's going to be upset because it doesn't have this layout component, but we have that next. So we can make a new like components folder, make this layout.tsx file, and just copy and paste that layout. And then just a little bit more styling, just because I had to include the styling. This is our globals.css file. All right. So the first like real part of our front end is setting up our API endpoints. And basically there's going to be 2 endpoints, and one is to get the registration options for the registration ceremony, and then get in the authentication options for when we do when we're signing transactions. So I'm just going to make like this get registration options file in the API folder. Yep. In here. And just copy and paste. So what does this look like? Basically, we're passing in this like RPID, which is like the relaying party's ID. The name, which is the relaying party, is basically just like your app. So it's like your app's ID, the name, and the username. So the username is really like the passkey name that has that like input. So like in the demo, it was just like hello. And we're basically just creating this like options object. We're also saying here that like it requires that there's user verification, which is different for different kinds of authenticators. And we're only supporting the specific algorithm, which is like, it's called -7. But it's basically, this is the like algorithm, the encryption algorithm that's supported by the P256 verified precompile. So it's like we need to make sure we're using this specific one because WebAuthn supports a bunch of different signing mechanisms, basically signature schemes. So they're not all supported like to run, I think, today and on smart accounts. So we have to say like the specific one is. Yeah, and so this is just like this special function provided by simple WebAuthn that just has to be run on the server. And we'll use that on our registration page. Okay, so next is authentication options. And really similar. It's just like generating this options object that is needed for the ceremony. And here, yeah, we're passing in like the challenge here. I guess we should be passing in the ID, which is just localhost for now, hard-coded. So yeah, it's just generating these options, passing the challenge in to be signed. And this is what's going to be like our transaction. Oops. Okay. And if you want, I just put this code here. If you're like, you run the code and you like console log these options, you'll notice the challenge doesn't look exactly like the challenge you passed in. And you might be like, is that really the challenge? It's because basically this challenge is being passed in as like a hex value, and it's getting changed into like a base 64 URL. And so you can decode that with this simple WebAuthn like helper function. Just if you want to be like, is that really encoded right? Yeah. That's another thing about WebAuthn is that like there's a lot of base 64 URLs, as you'll see right here. There's like a good amount of like sort of conversions we have to do. And there might be a better package library for this at some point soon. So yeah, we're gonna make this utils file. So we have our API endpoints now. We have our styling, our homepage, local environment variables. And we're gonna make a utils folder. And this first one is going to be for string conversions. So this is just, like I said, like doing some conversions that we need for different encodings. Nothing too exciting here. Next, we have a transaction file. So utils.tx.ts. And this one is a bit more exciting. Okay, so we have one more utils file to add here. We have this function to like get a transaction and just like passing in some data. So it's just something to help streamline like getting the gas price, getting the knots, getting these paymaster overrides, which is what allows the transactions to be gasless. So again, there's more detail like about all this sort of like paymasters and like how basic smart accounts work in our other tutorials. So I won't go over it too much, but basically we're just adding this paymaster as like an override in the transaction. So it knows to go like check the, or just have the paymaster contract pay for it. Yeah, and then the type is going to be 113, and this is also important because this means that we're like using this EIP 712. I think it's like signed typed data. So yeah, we have this function just to get a transaction, get the paymaster overrides, and then we have a function to register a key in the account. So this is calling that like update R1 function. Here, update R1 owner. So this is when we register a new passkey, we can update that. And because we said only the smart account itself can call it, then we need to use this like actual wallet with a private key that we used to generate the actual smart account. So this one is a little bit special where we like actually need a private key here. And for the other transactions, we don't need a new private key. We just need the WebAuthn signature. So that's why it's kind of on its own here. Okay, so last utils file is this WebAuthn one. Just copy that. And this has a bunch more utils here. There's like function for the authentication process. It just gets those options from the endpoint that we made and starts the authentication process, which is this function is like provided by simple WebAuthn. We have a function to sign and send a transaction. So we are essentially, we get this like authentication response when we run this function. And we can extract or essentially create that signature that we saw earlier, which is like this encoding of these three things together. So if we like look at where that is, basically we get this like authenticator response to authenticator data, response.client data JSON, response.signature. So we have this like response object from when we do this authentication process. And when we actually like run this locally in a sec, like I'll log this out so you can see what it looks like. So yeah, we're getting back these three pieces of data and we're just like encoding them all into one custom signature. And then we're adding that custom signature, like basically appending it to the transaction. So yeah, this back like in this authenticate function right here, this challenge that we're passing in is the like transaction that we're basically creating here. So yeah, these are our utils. You'll see it also like on the actual pages. So yeah, some helper functions to get like the data to sign, to get these RNS values, extract the public key from the authenticator data. Yeah, those are all of our utils. Okay. I'm like trying to get this wrapped up in time. I think we'll make it. Okay, a few more sections, two more sections. We have these like hooks to add, and then finally our pages, and then we can actually run the app. So I'm gonna make this hooks directory. Oops. And it says, oh, no, these are not the ideal implementation. This is just something I made to get this like demo working. So you can read fully in the tutorial, like why this is not great and what would be better. Yeah, basically I'm creating this like use account hook, or it's mostly for the wallet one, but there's this use account hook just to save the account we make in local storage. So that way, basically you can just come back to the app and remember your account and you can continue to sign transactions. And we have like a use wallet hook. And this doesn't save anything in local storage. It sort of just temporarily saves the random wallet used to generate the smart account. So we can use that private key when we register a new R1 owner. Okay, and then we need to add these hooks by like wrapping them around our app here. And also adding this like provider, or the network provider. Okay. So we have that done. Finally, we're adding the pages. Okay. So first is the create account page. And I'll go through this code. So this is where we're using that contract factory to create a new smart accounts. We are, let's see, we have this rich wallet. We're sending test funds to a new account, and when we deploy a new account, it's just generating a random wallet and using that like wallet as the like owner of the new smart account. We just generate some random salt, get our paymaster overrides, so it's all gas free, and deploys a new account. Okay, so yeah, so it deploys a new account, and then they'll get like 100, I think, yeah, 100 test ETH, just so we can try out the transfer function. But theoretically, it's gasless, so if you just wanted it to mint an NFT, you wouldn't need to have it get test funds. Okay. Next is our register key page. And this is using that like wallet hook, so we can have that private key. It does a quick check to see if there's like an authenticator available on the platform. We fetch those registration options from our endpoint, and we're just using localhost as like our ID and name here. So when you register a key, it's like basically tied to your application, essentially. And we register the key. We do this start registration ceremony. And then once we go through that, we extract the public key from that authenticator data response. And then we can run that like set registered public key or register key in account function to actually register it as like an authorized sender. Okay. So we have the first two parts, the first two ceremonies, basically. Or wait, no, sorry. This is all the first ceremony of like register a passkey, we create an account. Next, we want to actually use it. So we have this like transfer page to actually try authenticating with this passkey and sending some amount. So, oops. So we have this function to just like update the balances so we can see that the transfer has worked. And basically looks a lot like your basic Ethers transfer. Like we're using that get transaction function from our utils to create this like raw transaction. We're using this EIP 712 signer to get like this, basically put it in the right format to sign. And then let's see, we are turning it, or yeah, just putting it into a string and authenticating it. So that authenticate function is basically, if you remember, like passing this transaction as a challenge to the authentication options endpoint, and then actually authenticating with that. So yeah, we're just basically creating the transaction. We're passing it to WebAuthn to get signed, and then we're actually sending it. Once we have it signed, like by WebAuthn, we send it to like broadcast the transaction, basically, with that custom signature. So yeah, that's our that's our transfer function or page. And then the last one is mint, which is where we mint the NFT, and super similar. So here, basically the main difference here is that we're calling a contract function instead of just sending a simple transfer. But basically this whole flow is the same. And then we're just getting like the logged SVG like from the NFT receipts, from the transaction receipts. Okay. So that's a lot. I hope I can like, as I demo it, it starts to make a little bit more sense if you're still a little bit lost. So going to start this up. We're running at localhost 3000. And yeah, so let's see, when we create an account, oh no, let's see. Pages, create account. Right, sometimes this import is kind of funny, where it will change. So if this happens to you, you can just like delete this, and hopefully the variables, yeah, it gets it like from the correct source here. Okay, there we go. Just had to fix our imports. Okay, so I've already tested this out, so I already have like an account on local storage. We can just like create a new account and this will update. And then let's register a passkey and let's like just console log some things so we can see like what's going on. So we have, let's see, let's go to the register page. And let's log the, okay, so we're already logging the public key. Let's also log the response. Okay. Also, I think I have a bunch of public keys already set. So yeah, you can like go to this like Chrome settings passkeys page and manage them if you do a lot of testing like me and you're like, I don't want to have a million passkeys. Should have done that before. Okay. So I can just say like, I'll call this Krenza. And so this is like registering a new passkey, use my fingerprint to authenticate, and cool, I created this new passkey. And we can see like this is the public key it extracted here. And this is what the registration response looks like. So we have like, yeah, everything is base64 URL. If you're like, why does this look so weird? WebAuthn and base64 URL. It's like, it's a thing. And so we can see like it uses the right public key algorithm. Yeah, we have our registration. And then it also, during that transaction, or yeah, during that whole process, we registered that to the smart account that I made. So now we can try it out. So we can, like, we have this 100 test ETH right here. And let's also do some more logging. We can just console log this whole response, auth response. And in the WebAuthn here, we can console log this client data. Okay, I'm just going to transfer. We'll do 20 ETH. Use my Crinza passkey. And okay, cool. You can see it worked. These logs might be kind of small. There we go. So you can see like this is the authentication response. So it's like we sent the transaction as the challenge. Once it's authenticated, like this is our authenticator data, our client data JSON, our signature. And then the client data JSON, if you like convert it to a string, it basically looks like this. It has our like this type, which is like the authentication type, WebAuthn get. The challenge, which this is like the base 64 version of the transaction that we signed. And like the origin, cross origin. And yeah, sometimes it adds like a little note here about how this data can be potentially changed in the future, or so don't rely on the structure. Kind of ignoring that in this example, just so you know. So the way we extract the challenge in the contract is like it sort of just assumes like, okay, I know the length of these characters, I know the length of the challenge, and I'm just going to extract that. And yeah, if you like convert this, or if you convert the like in the actual, go back to the, where is it, account here for challenge. So if you convert the actual transaction hash to a base 64 URL, it should exactly match this challenge, essentially. So that's what we're checking for, like in our smart account. Yeah, and then I got our receipt, so it worked. And then, yeah, the last thing you can do here is mint an NFT. And it worked. Okay. Another thing you can like try out is just like try to break it. If like, oops. So here's another thing I added is because you need the private key to register a passkey. This setup isn't ideal, right? Because it's like, okay, I registered a passkey. Now I would have had to store this like private key, the private key to this account to create a new one. The upside is even without that, I can continue to use this. And like, even if I close this and come back, like my account's saved in local storage. If I were to delete my local storage or something and delete my passkey, like I would lose access to that 100%. So this example is like definitely not like something you can just like use in, you know, with real money like right now, because there's sort of these like gaps there, but they're sort of intentional because I wanted it to make something that you could like run with it in different directions, because I think like there's so many different ways you can like sort of apply this kind of validation basically. So yeah, if I want to test it out again, like say create a new account, and then now it's using like the new account I created, and I try to use the Crinza passkey, it should fail. Yeah, so we can sort of see like it works, it's working there, where like if we're signing with a different passkey that's not registered, it will fail. And we can try, you know, setting up a new one, seeing that that works. So it's like the Sarah one should work, but the Crinza one should fail. So yeah.
This is awesome.
Thanks. Yeah, I think we're like, I made it just in time. I don't know if we have like questions, if anyone was following along, or like something just didn't make sense, if we have like any questions.
We don't have questions at this point, but I'm gonna give them time to ask questions. Like if you have any, feel free to even like drop. Like if you haven't been able to like follow along to this workshop, like feel free to like try it after this. And like if you have any questions, you can DM us, like DM Sarah or DM me, or you can also join our ZK Sync Builders group, and we'll be able to answer you guys there as well. But just to recap, like what we have learned, what we have done so far is we created 4 contracts, right? We created the first contract we created was general paymaster.sol. Then it's kind of again like it says like the even like the file name says that it's kind of like a general paymaster contract where you can sponsor transactions, right? The second contract we worked on was the NFT smart contract, right? So it's kind of again like the Zeek NFT contract that we built. The third one was the account abstraction factory, which was again like a factory contract where you can deploy new instances for the smart accounts. And then the last contract was the accounts itself, which was the contract for the smart account, right? And using all these 4 account like contracts, we were able to like I would say like we were able to do 4 actions. First was to create this a new account basically, and the second action that we did was registering like a new passkey, right? And then we use that registered passkey to transfer, like do a transfer transaction or like transfer ETH. And then the last action that we did was basically the mint itself, which like these two, the last two transaction that we did was gasless because of the paymasters. Um, yeah, so if you guys have any questions, feel free to ask. I know we are a little over time and we might have missed a meeting, but it's fine. If you guys have any questions, feel free to ask. This was the second builder sync. We did one before with Patrick Collin. We did one with Cypherin. There was first, I think, one of these live streams that we did before as well. So this is a good way for us to um, yeah, just like show like what's uniquely possible on zk-sync era, like how you can implement native account abstraction, how you can work around with paymasters, how you can build ux which is ready for the end users, right? Yeah, so I think the use cases are right there to explore. We are going to give you some guidelines, we are going to give you like some directions, but I think at the end of the day, like you have to, like as a developers, as a builder, like you have to get creative with ideas and like how you can extend the functionalities that Sarah just showed right now, right? There's like a lot of things you can build just using the 4 things that you just have learned, right? um, yeah, I think we're going to do more of these. It's, I know like from our side we haven't been able to put a cadence, and we don't have like a proper time as to like when would be the next session, but promise, like I think yeah, right after this like we have to figure out like what will the cadence, so like all of you guys are prepared for the next session or the builders thing that we're going to do.
Yeah, and I just want to double down on, if you have any issues, please reach out. And we have like a developer discussions board. Like you can find the link in our docs, where you can like post any issues you have. And I'm almost 100% sure there are edge cases where maybe this app doesn't work for someone, and I'd love to find those. So yeah, please let me know.
Awesome. Yeah, I think we can end this here. I don't see any questions, but again, like if anyone here who couldn't like walk, like just do a code along with us, like feel free to test this out. We have a written guide ready. I've already plugged the links in the chat, but I'm also gonna drop, like we're gonna make like a tweet from the ZK Sync Devs account, and we'll post all the links, all the tutorials, all the relevant guides and resources that we have around signing transactions using WebAuthn there. So like you have like a full scope of learning materials ready. All right.
Awesome.
Sarah,
Yeah, thank you so much.
Same here. All right. Bye, guys. We'll see you probably next time. All right. Bye.